Good morning, everyone. I gave you guys a little assignment the other day, and a lot of you reached out to me because you had a question, and rightfully so. There was some notation there you'd never seen before, although a lot of you were able to figure it out. What we're going to be talking about today is called higher order derivatives. Okay, higher order derivatives. And here's the idea. If I give you f of x equals, let's say x to the fifth, and I say, what's the derivative of that function? You're going to say, is it a one-step product, quotient, or chain? You're going to say it's a one-step, no big deal. And you're going to take derivative of the left side and derivative f of x is f prime of x. You're going to take derivative of the right side, you're going to get 5x to the fourth, and that's going to be all set. No problem. That's f prime of x. You know the derivative. But isn't it possible that I could have started you with the function 5x to the fourth? Just started with that function and said, hey, can you find the derivative of 5x to the fourth? And of course you could, because you'd ask one step product quotient chain, and it'd be a one step of the free ride, and you'd get it done. So here's the thing to remember. Derivatives are functions themselves, and functions have derivatives. So that means you can have the derivative of the derivative. So if I want to go further with this one, I would take the derivative of the right-hand side and derive 5x to the fourth, free ride for the 5, going to do 4x cubed as a one step. That's obviously going to give me 20x to the third. But what do I do on the left-hand side? Well, I need to take the derivative of f prime of x. How do we take a derivative? We put a prime symbol on it. So if I start with f prime of x and I take the derivative of f prime, I got to put a prime symbol on that. And that leads us to what we call f double prime of x, okay? F double prime is the second derivative. From here, you can see this is going to continue because, again, 20x cubed is a function all by itself. So I could take the derivative of 20x cubed, one step product quotient chain. We're going to say one step with that free ride. That's going to get us 60x squared. But on the other side, what's the derivative of f double prime? Well, you're going to go ahead and you're going to take f double prime of x, and you're going to have to put another prime symbol on it. That's going to take you to f triple prime, okay? And from there, we could keep going. The derivative of f triple prime of x, well, derivative of 60x squared, one step with the free ride, we're going to get 120x. And on the other side, now this is where it gets interesting. We would want, based on what we've said, to go f triple prime of x and then throw another prime on there. But when you get to this many primes, it becomes really difficult to read them, okay? So the notation changes. The notation changes, and what we do instead is we write f, and then in parentheses up there, we put a 4. And that 4 means the fourth derivative. So that's the notation you're going to see. You're going to see double prime for the second derivative, triple prime for the third derivative. But for the fourth derivative, you're not going to see that quadruple prime symbol. You're going to see f, 4 in parentheses, and then x. And that's going to mean the fourth derivative. Of course, you could keep going, and now it makes perfect sense. The derivative of the fourth derivative is going to be the fifth derivative, and that would be 120. And then from there, the sixth derivative and every derivative after that would be zero, okay? Because you could keep going and taking derivative after derivative after derivative. This is, again, higher order derivative. What would Leibniz say about all this? Well, let's take a look. If Leibniz had a function and he wanted to take the derivative of y, he would say, let's take the derivative by using this symbol, d something over dx, right? That's his symbol for take the derivative with respect to x. So what is the derivative of y in the world of Leibniz? Well, simple. The derivative of y is nothing more than literally saying the derivative of, and then what do we put in that blank? We put the y. So we get the derivative of y. And Leibniz's first derivative is written dy over dx. Well, what would Leibniz's second derivative look like? Well, his second derivative would be like saying, let's take the derivative, but this time we're taking the derivative of the derivative. So Leibniz's second derivative would end up starting like this. And Leibniz saw this notation. He said, well, let's make this simple. My notation is based on the idea that derivatives kind of look like fractions. So we treat them like fractions. So he's going to continue with that theme. He's going to treat this kind of like it's a fraction. When Leibniz sees this, he thinks it reminds him of multiplication. So he sees numerators going across and he's got that d and that dy. So what does Leibniz say to himself? Well, even though it's not really multiplication, I want the notation to reflect multiplication. So he calls it d squared y. And then when he gets to the denominator, what does he see? Well, he sees the differential dx times itself. So he says, I've got dx and dx. I'm going to call that dx squared. Now, that dx is one thing. It's the differential. It's not d times x, it's dx. So Leibniz does not feel the need to square each individual piece because dx is one thing. So he just writes dx squared. And all of a sudden, we've got the second derivative, Leibniz style. Okay, this is going to be the second derivative. By the way, again, compare and contrast, that is also equal to f double prime of x, which is also equal to y double prime. So those are all different ways to write the second derivative. Well, if Leibniz keeps rolling with this, what's he going to do next? He's going to be like, okay, let's take the third derivative. But what does that mean? It means the derivative of the second derivative. So he's going to write the derivative of the way you see it. He's going to put that second derivative in there. And what can we find? Well, he continues with this idea of making it look like multiplication. The numerator is now going to be d cubed y over dx cubed. And that will be the third derivative in Leibniz notation. Again, that would be f triple prime of x or y triple prime. Leibniz is going to continue with this notation, and he can take any number of derivatives he wants. So if he wanted to take the 12th derivative, what would that look like? Well, it would look like the derivative of the 11th derivative. But what you can see is for every order of derivative, what I mean by that, okay, this is the third derivative. That's the third order derivative. This is the second derivative. That's the second order derivative, okay? If he wants to take the 12th derivative, well, that would mean taking the derivative eventually of the 11th derivative. And the 11th order derivative in Leibniz style would be d11y over dx to the 11th. Realize I probably shouldn't have done 11. That looks like a double prime there, but that's the number 11. And when Leibniz gets that, he'll do the 12th derivative, d12y over dx to the 12th. So this would be the 12th derivative. The general notation, what's it going to look like? The general notation for Leibniz for his nth derivative, where n can be any whole number. The nth derivative will be dn of y over dx to the n. And that is because we're going to have d over dx n times, because that's going to be the first derivative. We take a derivative again, that'll be a second derivative. We take a derivative again, that'll be a third derivative. We take a derivative again, that'll be a fourth derivative. And for every time we take the derivative, we have one of these d over dx's. And that means when we think about this way Leibniz says with multiplication, we're going to have the same number as the order of derivative that we are taking. Okay? One last thing on this very quick lesson this morning. When we think about the family of functions, and we really use that word family, we're serious. We kind of think that, y is the starting point, okay? And from there, we derive y, and we literally derive, we take the derivative of it, and that becomes dy over dx or y prime. So I'm going to write this in a couple of different ways. Dy, actually, let me rewrite that. Dy over dx. If we derive dy over dx, what are we going to get? Well, we're going to get d squared y over dx squared. And this is going to continue as long as we want it to, okay? So that's the Leibniz notation. If we think about it using the function notation, we start with f of x. Where do we go next? We go to f prime. That derivative is f double prime. That derivative is f triple prime. That derivative is the fourth derivative. That derivative is the fifth derivative. And it's going to continue like this on and on. Well, we're going to refer to this as the derivative family, or the function, actually, I guess we like function better, the function family tree. And we're going to think of this as going down, moving down each time. See if I can get a good arrow there. Moving down each time, just like my arrows today. There we go. One generation. And that's the phrase we're going to use, one generation. So anytime you take a derivative, it doesn't matter where you are, you're moving down one generation. From the fourth derivative to the fifth derivative is one generation. From the function to the first derivative is one generation. And we're going to refer to this as the family tree. It's going to be really important that you understand when I say, hey, what's the generation before? What's the generation after? If we were talking about the third derivative, the generation before is going to be the second derivative, and the generation after is going to be the fourth derivative. So sorry for any of the confusion that may have caused on that sheet I gave you the other day where you had some c double primes of t. All it means is the derivative of the derivative. I'm going to put together an AP Classroom quick assignment for you guys to practice higher order derivatives. So I'll have that ready in the class before your period is over. So if you have any questions, please reach out. Have a great weekend, everybody, and I hope to see you soon. Take care.